All right, this is a great question. Uh, it's got two parts. So one is this notation that we have to figure out for what is going on in this reaction, and then we have to solve for the E naught or the E cell for the reaction at standard conditions. So first thing, the way this notation is written, we have manganese going to manganese 2 plus at the anode, and then we have silver going from silver plus to silver solid. So we could rewrite this as Mn plus Ag plus going to Mn2 plus Ag. So we could write it, that's our rewritten equation if we wanted to think of it as a chemical equation. We're going from 0 to +2, so that's our oxidation. And then we have +1 to 0, so our reduction. Now, to find E cell, it is the E of the cathode, the standard reduction potential of the cathode minus the anode. We just determined that manganese was the anode here, and then silver is the cathode, so we would have 0.80 minus a negative 1.18. And so that is a positive 1.98 volts. So this notation is not written like a chemical equation, but instead is saying, okay, here's anode, which is always oxidation. And then here is the cathode, which is always the reduction. So anode first with oxidation, cathode second. So a little bit different than this more balanced chemical equation notation that we're used to. But eventually what it comes down to is cathode minus anode, which is 0.8 minus a negative 1.18, equaling a positive 1.98. And we remember we keep these both in their reduction potential. And there we go.